Okay, at first I want to thank you for joining this live session. Now let's get started. So last time we have completed unit 4, unit activity and then post test. So from today we'll start unit 5, periodic motion. Okay. And then in this lesson, our goal is to observe, analyze and predict periodic motion. That periodic motion is also repeating motion. And this includes such everybody motion such as child swing back and forth on a swing, an object bobbing up and down in a spring like that, or planet traveling along in an orbit around a star. These all types of motion is called are the examples of periodic motion. Okay. And then today our specific goal is to complete those two lessons. Periodic motion, that is the first one, and second one is mass on a spring. So these are the two lessons we'll complete today. And then whenever you have any question, please feel free to unmute and ask me question, or you can ask me question through chat as well. Let's start with periodic motion. The goal of this lesson is to define and describe periodic motion and solve the problems related to it. Okay. At first, we'll define periodic motion and define other terms that are used in periodic motion. After that, we'll go through the potential and kinetic energy of spring. And at the end, we'll solve some of the problems related to periodic motion. Okay, let's start with forces on a spring. Okay, and then let me grab my pen as well. Let's define periodic motion at first. When an object oscillates, that means vibrate back and forth. It goes back and forth in a regular cycle with equal time interval. We call this motion periodic. This type of motion is called periodic motion. Object oscillates, that means vibrates back and forth in a regular cycle with equal time intervals. Call this motion periodic. And in periodic motion, an object has one position where the net force equal to 0. Net force equal to 0. You can see here net force equal to 0. And that position is called equilibrium position. Equilibrium. So think about this word. First periodic, second equilibrium. Think about those words. Okay. So that means if we have a spring and then I just hang the spring like that. Let's suppose this is the spring. I just hang the spring and then I didn't hang any mass at the end of the spring. So that position is called equilibrium position. Now think about the spring hanging vertically from a block. Its length is the equilibrium position. So at the end of the length is the equilibrium position. The position at the end of the length is equilibrium position. When a mass is attached to the spring, the distance x that the spring stretches from the equilibrium position is called the displacement. So whenever we attach certain mass on the spring, it elongates, and that elongation is called the displacement. Yeah, that elongation. And then if the spring is moving back and forth, when it oscillates, that elongation or compression, both are the displacement of the spring. And amplitude is the maximum distance. That maximum distance that object moves from the equilibrium position is called amplitude. So these are the terms you have to remember: periodic motion, equilibrium, displacement, and amplitude. Okay, if you have any questions, please let me know. I'll give you some time. You can ask me question through chat as well. Okay. Okay, thank you very much. Now let's go to the next slide. Now let's define time period of a periodic motion. Okay. The time it takes for an object to complete one full cycle of periodic motion is called time period or just the period. Okay, and it is denoted by the letter capital T. And if we have multiple cycles, we divide the total number of seconds, that is total time, by the number of cycles completed. So that means period is equal to total time over number of cycles completed. And you can write that formula, okay? And the inverse of the period is called frequency. Inverse of period is called frequency. And this is also the measurement associated with the periodic motion. And frequency can also be defined as the number of complete cycle, that is number of complete cycle and oscillation makes per second. Okay. Number of complete cycle and oscillation makes per second is also defined as frequency. The unit of frequency is Hertz or per second. So time period and frequency as an inverse relation, we can see from here. Time period is 1 over frequency. Frequency is 1 over period. Here F is frequency, right? Okay. P is period. Period. Okay. Now let's work on some of the problems related to time period and precession of spring. Okay. At first, I'll give you some times to answer each of those questions and then I'll answer it, okay? This question is which quantity measures the maximum distance an object on a spring moves from the equilibrium position during oscillation? Think about this question and then try to answer it. There is no wrong or right answer. Try your best and then I'll answer it again, okay? Okay, thank you. Oh, let me answer it. The correct choice for this question is C, that is amplitude. Okay. Let me define amplitude. Amplitude is the maximum distance an object on a spring moves from the equilibrium position. That means maximum displacement from the equilibrium position is amplitude, and force, restoring force, that is unrelated because distance and force are unrelated. So this choice is incorrect. And frequency is the number of oscillation per second. So this choice is wrong. And period is the time for an object to complete one oscillation. That is the definition of period. So the correct choice is C, amplitude. Now let's go to the next question. Okay. For this question, I'll write formula and then I'll give you some time to work on this question. If the period of a spring is 5 seconds, period is denoted by T, is period. What is its frequency? And then we have to calculate frequency. Frequency is equal to 1 over period. Use that formula and then calculate frequency and answer through poll. Okay, thank you. Let me answer this question. Frequency is 1 over time period. So 1 as it is, and time period, you can see here period is 5 seconds, 1 over 5. And then use calculator. You can use a Desmos or any online calculator, or if you have physical calculator, you can use that physical calculator. 1 over 5 is 0.2. And the unit of frequency is Hertz, 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 or unit is per second as well. So the correct choice is C. One. Now let's go to the next slide. Now let's talk about Hooke's law. So this Hooke's law defines the relationship between force exerted on the spring and the displacement caused by that force. Okay. And then let me read that for you. So Hooke's law states that the force exerted by spring is equal to the quantity called the spring constant multiply by the distance the spring is stretched or compressed from its equilibrium position. So that means that force is restoring force that is equal to the product of spring constant and distance the spring is stretched or compressed. And then if you have pen and paper, please make sure to write that formula. Here F is restoring force. And K is spring constant. K is called spring constant and K I'll simply write displacement, okay? It can be displacement due to elongation or compression. And then this negative sign is due to the fact, you see that negative sign? Negative sign is due to the fact that force and displacement always act in a opposite direction. Okay? And then I'll explain through this diagram as well, okay? So in the beginning, when we do not apply any force, displacement is 0, you can see here. It's around 40 centimeter at that time, you can see here. Displacement is 0, force is also 0. That is the equilibrium position. Equilibrium position. Equilibrium position, where displacement is 0, force is 0. At that time, the velocity of the spring will be maximum whenever it goes, when we hang any object, and then if it goes up and down, at that time, equilibrium position, velocity of that mass will become maximum. And then if we apply certain force, and then now we can see here spring is stretched, and that is X, that is elongation X. And if we compress, that X is displacement due to compression, this X is displacement due to elongation. In this case, X is greater than 0, force is less than 0. That means we can see here X acts, but X is acting vertically downward and force is acting upward, restoring force. In this case, X that is elongation, displacement is acting upward and force is acting, restoring force is acting downward. That means force and displacement always act in an opposite direction. Okay. So this is all about Hooke's law. And then also I have clarified why we do have negative sign in front of this law. Now let's go to the next slide. Now let's talk about potential energy stored on the spring. Okay. Whenever we compress or stretch the spring, there is elastic potential energy stored on that spring. And then we'll use Hooke's law to calculate that potential energy. That means whenever we applied certain force to a spring, we can see either elongation or compression. And that force is directly proportional to displacement. Then we can see a straight line, that is force is directly proportional to displacement. And then area under this curve, force versus displacement curve, gives the potential energy. Sorry, that area. area under the curve of force versus displacement graph gives potential energy. And then this is the area of a triangle, that is 1/2 times base times height. Here base is x, that is displacement, and then height is force, that is k times x, negative k times x, and then we'll ignore negative sign because potential energy is scalar quantity. 1/2 base times height, and it becomes 1/2 a times x square. So that is the potential energy. And then write that in your notebook. This PE is your potential energy of spring. Energy of spring. Here K is spring constant. X is displacement. And this displacement can be due to elongation or compression, okay? So this is all about potential energy of a spring. Now, let's go to kinetic and potential energy. We have already talked about potential energy of a spring. Now, if we attach certain mass at the end of the spring and the spring is moving back and forth, then due to the mass and velocity of the spring, that spring will also has kinetic energy. Okay, and then total mechanical energy of the spring is sum of potential and kinetic energy. That is E total is, that part is potential energy. PESP, potential energy of spring, and this part is kinetic energy of spring. AE, kinetic energy of spring. So in that way, we can calculate total energy of the spring. Now let's work on some of the problems related to Hooke's law and then kinetic and potential energy of the spring. And for each of the problem, if you need formula to calculate any answer, at first I'll write formula and then I'll define those terms as well. And then I'll give you some times to answer that question. The question is, what is the difference between the energy of spring A stretched 0.6 meter and spring B stretched 0.3 meters if they have the same spring constant? And then we have to compare in terms of potential energy, and then there is kinetic energy as well. But if we have displacement and then spring constant, then we'll use potential energy. Let me write that formula. So potential energy of spring, SP is for spring is 1/2 times K is spring constant and X is elongation. Here in this case, X is equal to, for spring A, X is equal to 0.6 meter. Spring B, X is equal to 0.3 meters. Use those information and try to answer this question, okay? Let me launch polling. Take your time and do it slowly, okay? We'll have enough time. Okay, thank you. Now let me work on this problem. The correct choice is A, that is spring A has more potential energy than spring B. As you can see here, potential energy directly proportional to x square. So let's calculate potential energy for spring A, okay? potential energy spring A is 1/2 K spring constant as it is, x square is 0.6 square is 0.36. And then for spring B, same thing, potential energy spring. I'll write A for spring A, B for spring B, okay? 1/2 K times x square is 0.3 square is your 0.09. If we compare those two, potential energy of spring A is greater than potential energy of spring B, because did you see 1/2K, 1/2K is exactly same, and 0.36 is greater than 0.09. So that means spring A has more potential energy than spring B. I'll pause here for some time. If you have any question, please let me know on this problem. Now let's go to the next question. This question is about Oakes law. Using Oakes law, what happens when the displacement is triple? I'll give you hint here. So according to Oakes law, force is the product of spring constant and displacement. That means force is directly proportional to the displacement, directly proportional to the displacement. So use that information and try to calculate what will happen to the restoring force or amplitude when displacement is triple. Let me give you some time to think about it and answer it, and then I'll answer it. Thank you very much. Now let me answer it. So we can see here force is directly proportional to displacement. Then if displacement is tripled, the restoring force will triple. So the correct choice is the restoring force is tripled. We can think about this problem in another way. Let us suppose F dash is the new force when displacement is triple, that is negative K. Now displacement is 3 times X. So let's rearrange it and pull that 3 in the beginning. So it becomes 3 times negative Kx. Negative Kx is the restoring force in the beginning. So 3 times F. So that means the restoring force is tripled. We can see here, restoring force is tripled. Now let's go to the next question. Okay, now we have finished some of the questions related to Oakes law as well. Oakes law and potential energy stored on the spring. Now let's start another lesson, mass on a spring. In this lesson, most of the content are exactly similar to the previous lesson, that is periodic motion. And then we'll only introduce few new concept, okay? That is the definition of simple harmonic motion. And then how can we calculate time period of a spring, time period of a mass on a spring. Let's start with time period on a mass on a spring. So as we know that period of a spring is the time in second it takes for the spring to make one complete cycle. And then if we have a mass on the spring, at that time we can use this formula to calculate time period, or simply period. E is equal to 2 pi square root m over k. Here m is mass on a spring. Write that. You can write that formula in your notebook. Mass on a spring, and then k is spring constant. K is spring constant. And then that motion of a mass on a spring is always the motion of mass on a spring is called simple harmonic motion, because that motion of a mass on a spring is back and forth like that. It goes up and down. And then that type of motion is also called simple harmonic motion. Okay. Let's go to the next slide. Now let's work on a problem related to this motion of mass on a spring. And then also we'll work some of the problems related to Hooke's law. Okay. This first question is for this lesson. If an object on a spring becomes 4 times massive, how would that affect the period of its oscillation on the spring? And then I'll write the formula to calculate period of oscillation, that is T is equal to 2 pi m over K. Mass on this m is mass on a spring. You can see here period is directly proportional to square root of m. Okay, square root of mass on a spring. Use that information and try to answer this question. Let's see, and then I'll answer it. Thank you very much. You have answered it correctly. So the correct choice is the period would become twice as long. Correct choice is C. And then let me explain it briefly. So period is directly proportional to square root of m. And then if the spring becomes 4 times massive is square root 4 times m, and square root of 4 is 2. So the period becomes twice as long. Or you can think in that way, new period T dash is equal to 2 pi. Now mass becomes 4 times mass over K. Square root of 4 is 2. Let's pull out that outside. Put it here, 2 times everything as it is, m over K. That part is T. So it becomes 2 times T. So that means the period would becomes twice as long. And then I hope you already knew this concept because you answered it correctly. Now let's go to the next question. This question is, which statement describe the motion of a mass on a spring? So mass on a spring is it goes back and forth like that, or think like up and down. So, and then that kind of, and where force and displacement always act in a opposite direction, and force is directly proportional to displacement. That type of motion is called simple harmonic motion. I'll answer that question. So the correct choice is B. It exhibits simple harmonic motion. Correct choice is B. It exhibits simple harmonic motion. Now let's go to the new next question. The question is, when is the velocity of a mass on a spring at its maximum value? So that means when the velocity of the mass that is attached on a spring as a maximum value. So I'll answer this question as well. So let us suppose we have a spring like that, and this is the equilibrium position. Okay, and then if we have certain mass here, and then let us suppose stretched all the way from here to here, that is x. And then if we release it, it will goes back and forth. So that means It will go all the way back here at certain point. That is also your compression, that is X. And this is a equilibrium position. Equilibrium position. When this is the position when we didn't hang any mass, okay? Equilibrium position. At equilibrium position here, net force is always equal to 0. At this position, X is equal to 0, we don't have displacement, net force is equal to 0, and velocity is maximum. Maximum. And at points A and B, I would say like those are the extreme points. At the 2 points, velocity is 0. Because at that points, for fraction of second or for the mass on a spring stops and then come back to the equilibrium position. Okay. So correct choice for this problem is when the mass has a displacement of 0. Okay, now let's go to the next question. Now for this question, at first I'll write the formula to calculate restoring force based on a Hooke's law, and then I'll give you some time to answer this question. Question is, what is the restoring force of a spring with a spring constant of 4a? That is K is equal to 4a. Restoring force is F. And stress displacement of 3b, that is X. And we can calculate restoring force using the formula F is equal to negative K times X. Use that formula and try to calculate restoring force and answer through the poll. Let me launch poll again. Take your time, do it slowly. Okay, let me end polling and then I'll answer this question. Thank you very much. Where is my pen? Okay. Let me plug in those values. Okay, restoring force is F and then equal to negative sign as it is. K is equal to 4a, you can see from here. And displacement is 3b. Stress displacement is 3b. And then multiply number 4 times 3, negative as it is 12, and put your variable at one place, a times ab. So the correct choice is C, that is negative 12 ab. I'll give you some times. And then if you have any question, please let me know, okay? And then if you understood this question, you can give me a thumbs up, thumbs up. And then there is another question exactly similar to this, okay? Okay, let's go to the next slide and then you will work on this question. Okay, again, I'll write the formula for you. That is restoring forces negative spring constant times that is the displacement due to stress or compression. So use that formula and answer this question again. And please make sure to use calculator whenever you multiply those two numbers, okay? In this case. Yeah, that's correct. Thank you very much. write it here. So negative K is 55, and then X is this time displacement due to stress 0.35. That is around negative 19 newtons. So the correct choice is D, negative 19 newtons. Now let's go back. Sorry. So today we have started unit 5 and completed those 2 lessons, periodic motion and mass on a spring. Okay. And then I always encourage you to maintain your pace. We have already started unit 5. So if you are falling behind, please make sure to work hard so that you can catch up soon. Okay. And if you have any question, please feel free to stay here. If you do not have any question, you can leave this live session. Have a great day. Bye bye. Thank you very much. Thank you. Bye bye.